Thank you. So what I'd like to talk about is one level below that. I think Ken gave a very good high-level overview of what this new urban strategy should be like. And what I'd like to talk about is the energy networks, the mobility networks, at the level of the technology required to implement this. And this diagram here shows a concept of what we call mobility on demand, which is essentially a fleet of lightweight electric vehicles distributed around the city. And when you need a vehicle, you simply walk to the closest station, pick up an electric vehicle, swipe a credit card, get access to it, and then drive it to anywhere else that you want. And this is a very new use model, quite disruptive to existing models. And coupled to that is the need to have a communication network that gets information to the users of where the vehicles are, where they could park, as well as the energy level of each of these vehicles. And what I'll talk about today is the development of two vehicles, and we've done a number of them. The one that I want to talk about is this new electric vehicle called the Persuasive Electric Vehicle, which tackles the issues of health and mobility, as well as the City Car, which is a long-term project, and its development. So the City Car is a lightweight electric vehicle. You saw a video of it earlier. It's very, very light and compact compared to traditional automobiles. It weighs about 1,000 pounds, and that's 3 times that of less than a traditional automobile. It also utilizes in-wheel electric motors, which are highly efficient, about 90% compared to 20% or less for gasoline-powered vehicles. The vehicle has a fuel economy of over 200 miles per gallon equivalency, which is 5 times that of a comparable smart car. And the vehicle also has unique maneuverability and high agility to move around, so you don't need to parallel park in the way that you do. And this is just simply better than traditional parking. And we've done a number of case studies to look at how this is feasible in urban areas, and some of them are actually quite nearby. The city of Hong Kong actually has very high rates of taxation for car ownership. It costs 3 times that of the United States, and so this could fit quite well there. In Singapore, this could fit as an extension of public transit, where you don't necessarily have to own a car. You can just use this as an extension of public transit. And we looked at Europe. In fact, we're collaborating with a group in Spain to develop and to manufacture this vehicle for production. And of course, the streets of Europe being very narrow, this would make a lot of sense. What's also important is the collaborations that we've set up with Media Lab sponsors and members. And this is important to not only bring our concepts to reality, but the need to actually work in these complex systems is very, very important. So the project that I'll talk about is the Hiriko project. And you might be wondering what that means. Hiriko sounds very Japanese, but it actually is a conjunction of Iri, which is of the city in Basque, and Ko, which is short for coche, car in Spanish. So this is the name of this new product, or this new company. And the company is based in the Basque region, which is right on the edge of France. It's on the northeast corridor on the border of France. And we've set up a collaboration with one of the Media Lab sponsors called Denoken, and they've set up a project where we've involved a Formula One engineering team, local automotive suppliers, and then our team as well. And what we've done is taken this concept we've developed over a number of years with Media Lab sponsors and spent the last 2 years developing this for production. And here are some developmental sketches you can see where we're building 3-dimensional models, we're building physical models, and in fact, we created a very modular type of vehicle. In the same sense that cities can be modular, this vehicle is very modular. We've built this on in-wheel motor technology. The interior also has snappable components where the interfaces are standardized. And the bottom here shows all the companies that are involved in actually making the vehicle. Here you can see a picture of our robotic wheel, which integrates motors and steering and suspension all into the wheel. And on the top corner is our original concept, which we built at the Media Lab. And then the lower left is the actual manufactured piece. And you can see we've integrated a whole level of complexity and standard components that we can put together into this one module. This little animation this little video shows an early model that was built. That's Kanda and I actually actuating the whole thing by hand, but the whole thing will be actuated by real actuators. And we built a prototype model that was unveiled at the Spanish embassy and also unveiled earlier this year at a winery, which is one of the investors owns this winery. So I'll show in a second the real prototype. Here is a size comparison with traditional automobiles. And the number of mechanical components, the electronics, all the components are all built together in collaboration with our team. Here you can see some other slides of the development process. Here's Will Lark, one of the key designers of the project. This is his kind of size comparison with the body of the vehicle. And what I'd like to note is that usually in development processes and products, you'll notice that the products actually lose something along the way. And in the left-hand side shows our original concept. On the right-hand side shows the final concept. We were able to keep the core elements. The core elements included robotic wheels, by-wire control of the wheels, front entry and exit, as well as foldability. And that was important for city development. And so to unveil this is a sort of preview of what's going to be unveiled in about a week from now. This is the final prototype, a full-scale working prototype that we put together with this group. And this vehicle is the first instance of a by-wire vehicle. And we'll show you here, this is the rear trunk. So we spent the last 2 years basically getting this to this point. And the group that we're working with is going to build 20 of these for crash testing this year for homologation in Europe. Once we have those 20 built, we will then deploy this in about 5 cities. You can see the whole folding process. This is the interior control. The switch, the control can actually work in Japan as well. The vehicle controls switch from left to right as well, so we don't have to have different manufacturing process for that. This is the interior controls, which is using a tablet PC. Entry and exit is very, very easy in the vehicle. You'll see the whole thing fold up in a second. So the whole concept of this is to really get to the level of reality, to be able to build this and execute this and then implement. And that's really been our goal, is to take this to the next level. So that's the whole thing. So this will be unveiled on January 24th. Kent and I are going to be going there next week for the unveiling. And we're quite proud of this achievement, and we're really excited about deploying this in many parts of the world. The second vehicle that we've developed is called the Persuasive Electric Vehicle. It's a brand new concept. It's basically a 3-wheeler that's designed for bicycle lanes. It tackles the energy, congestion, mobility, and obesity issue, which is basically to combine pedaling with electric motor assist so that we can get that kind of exercise while we're traveling. It also has some coverage too, where you can be protected from the elements. It has a module for a baby carriage or other storage, and you can imagine this could be applied to many different areas. Let me wrap up by mentioning the energy networks. And the energy networks are very important because that connects all of these systems together. It's important to mention that with these electric vehicles, we can then imagine a whole network of vehicles plus charging stations and the energy storage required to be able to charge the vehicles, but also discharge the vehicles and provide power back into the grid. And this is important for a resilient city because we could imagine in the future developing a system like this where the vehicles provide power to the grid, provide also the use of the battery as a storage device. And that storage device allows us to look at renewables as well as providing backup power. And this allows us to also imagine a type of system where we can also have community heating and cooling as well. So let me hand it over now to Professor Kanda, who will talk about the application of this to the Miyagi area.